Hey guys! In this video we're going to talk about the mean value theorem, but we're going to start with Rolle's theorem because they start pretty much the same way. Now with Rolle's theorem it says that as long as the function is continuous and differentiable on a given interval and that the y value of the function is identical at the end points of that interval, then there has to exist at least one point in the middle where the slope is 0. So let's have this lovely function here, our example. If we just go ahead and take the derivative and set that equal to 0 and solve, we're going to find a number. Of course we will. But that doesn't necessarily mean it's what we're looking for. So to determine whether Rolle's theorem applies, we have to check certain things. The first is that it is continuous in this interval of 2, 3. Well, yes it is. Because it is a polynomial, it has to be continuous. The second thing we have to worry about is if it is differentiable in that interval. And in general, most of the time, as long as it's continuous in the interval, it's also differentiable, but just in case, you always have to think about that as well. So it is. The last thing we have to check is that, in this case, f of 2 is the same as f of 3. So that's where it gets just a little bit worrisome, because you can't immediately just look and tell, but we have our lovely magic wand of a calculator and we can figure it out anyway. So f of 2, if we put this into our lovely calculator, we will get 0. And if we do f of 3 into our lovely calculator, we will get 0 again. So 0 equals 0, and that checks out. Okay, so the conditions of Rolle's theorem have been met, and thus Rolle's theorem applies. Therefore, there has to be a critical value between 2 and 3 for this function. So take the derivative, f prime, so that's 3x squared minus 14x plus 16. Set that equal to 0 and solve. This is not easy to do, especially not in your head. So, how about use the quadratic formula? Negative b plus or minus the square root b squared minus 4ac all over 2a. Or, if you have it, you can use the quad program. Either way, I'm good. So x will be 8/3 and 2. Okay. So this means that we have two possible critical values at 8/3 and 2. Now, the guaranteed part, guaranteed to exist by Rolle's theorem. Now, technically, these two critical values are accurate. However, because we're looking at the interval from 2 to 3, notice that Rolle's theorem only is exclusive. Exclusive. So 2, even though we got it, 2 does not count because it is excluded by Rolle's theorem. So 8/3 is the only guarantee that we've got by Rolle's theorem. Okay. So the mean value theorem is just a little bit more intricate than the Rolle's theorem. So the mean value theorem says that if the mean value exists and is equal, then it has to be continuous and differentiable. Or, more accurately, strike that and reverse it. So, if the function is continuous and differentiable, then there has to be one critical value such that its mean exists and is equal. So let's think about this slightly differently, because yeah, it's kind of confusing to even hear. So we have this lovely word problem here. The lapse rate is the rate at which the temperature decreases in the atmosphere with respect to increasing altitude. So the higher you get, the lower the temperature. It is typically reported in units of Celsius per kilometer and is defined by gamma equals dt dz, where the lapse rate rises above 7 degrees Celsius per kilometer in a certain layer of the atmosphere. It indicates favorable conditions for thunderstorms and tornado functions, provided other atmospheric conditions are also present. Suppose the temperature at 2.9 kilometers is 7.6 degrees Celsius, and the temperature at 5.6 kilometers is negative 14.3 degrees Celsius. Assume that the temperature is continuous and differentiable at all altitudes of interest. What can a meteorologist conclude from this data? Okay, so the mean value theorem says that well, number one, we have to make sure that it is continuous. Well, they told me it is. And it's differentiable. Well, they told me it is. Okay. So now we're going to find the mean of the two endpoints. Okay. So the mean between the two endpoints. So we have to the right, we have negative 14.3 degrees Celsius minus, to the left, 7.6 degrees Celsius over 5,600 kilometers, excuse me, that says meters, minus 2,900 meters. Okay, so this will give me negative 8.1 degrees Celsius per kilometer. Do it that way. Okay, so this means that on average the temperature decreases 8.1 degrees Celsius per 1 kilometer between 2.9 kilometers and 5.6 kilometers. With only those two data points and nothing else, we can't really know anything much, but we do know that the mean value theorem only deals with the mean, the average. It guarantees, though, it does guarantee that there's at least one altitude between these two values that is perfectly negative 8.6 degrees Celsius. And thus, each altitude, the lapse rate, the gamma, is the same. That is pretty much all that the mean value theorem says. So for the Rolle's theorem, we're dealing with critical values, but for the mean value theorem, we're dealing strictly with the mean value and how it relates to the slope and the critical values. And that's all it does. So let's have a more theoretical example here. Determine the function satisfies the mean value theorem. So, is it differentiable from -1 to 2? Well, this is a polynomial, so it is not only continuous, it is also differentiable. So both of those two conditions are met. Those are the only conditions for the mean value theorem. So we want to find the point on which that it's guaranteed to exist by the mean value theorem. Okay, so we need to know g of -1 and g of 2. This time they don't give it to us, so we find it out ourselves, otherwise known as, well, do it in your head or do it in your calculator. g of negative 1 is 5, and g of 2 is 2. Okay, so if we put this into our mean value theorem, then 5 minus 2 over negative 1 minus 2, so that's 3 over negative 3, so that's negative 1. So this means that the average value between negative 1 and 2 is negative 1. This is the slope, the average slope between these two values. So to find the x value of the average, we would do the derivative. So g prime would be negative 2x. Set this equal to 0. No, excuse me, wrong way. Set this equal to negative 1. The negative 1 that we got from our average, and solve for x. So divide by negative 2, and x will be 1/2. So the guaranteed number to exist for this mean would be 1/2. That would be, it's not a critical value because we didn't set it equal to 0, but it is the slope, guaranteed to be the slope. So let's do one more. We have the same directions, but on this time we're having the given interval negative 8 to 8, and we have a cube root function. So, is a cube root function continuous? Well, yes it is. Is a cube root function differentiable? Well, yes it is. Okay, so those two conditions are met. So for the given interval, we need to know f of negative 8 and f of positive 8. Because we're going to do this. F of negative 8 minus f of positive 8 over negative 8 minus 8. So negative 8, f of negative 8 is negative 4 minus f of positive 8, which is positive 4, over negative 8 minus 8, which is negative 16 over, excuse me, no it's not, negative 8 minus 16. There we go. So that is 1/2. Okay. So the mean value theorem says that something's wrong. Why is that wrong? That's wrong. Why is that wrong? That doesn't make sense. Okay, so the mean value theorem says that 1/2 will equal the derivative, so f prime of the number, so f prime would be 2/3 x to the negative 2/3, and solve for x. So let's see, we get 3 x to the negative 2/3. Well, that'd be 1 over. So that would give me 1/3 x to the 2/3. There we go. So x would be 1/3 to the 3/2 power. Which doesn't really work well. be square root of 8. Right. So being square root of 8. So, rationalize the denominator. So square root of 8, so that's 4 times 2, so that's 2 square root of 2, so that'd be square root of 2 over 4 is x. So that would be the guaranteed critical, not the critical value, the guaranteed x value between -8 and 8 for this function if it satisfied the continuous and differentiable part. The problem is that it doesn't. I oopsed. You have to be continuous and differentiable on the interval for it to work. And it isn't. A cube root function does that, which means right smack dab in the middle, it is not differentiable. It doesn't work there. It is continuous, that's true, but it is not differentiable where the inflection point is. So be very careful. We did all of this work, and we didn't have to if we had just remembered that lovely little doohickey at the beginning. Oopsie. Oopses happen, even to me, obviously. So don't feel bad. Work with what you got and keep going. Learn from your mistakes. That's the biggest life lesson ever. Mistakes are fine. You just learn from them and keep going and hope you don't accidentally do them again.